Okay, so I think you have it down now. The deal is a orbit has a balance between the inertia. Now that's sometimes thought of as velocity, which means speed, right? What really it is the velocity, but it also relates to the mass of the object. But anyway, so you have the inertia and the gravitational pull have to be balanced for it to be in orbit, okay? And so let's have a little notes in your notebook, okay? So take out the same piece of paper you started last week, okay? So let's just make this a two-part lesson where you can just continue it on the same piece of paper. If you need another piece of paper because this one's all filled up, then, I don't know, you can turn it over or something. But here's the notes that I want you to write down. Okay, so a stable orbit happens when the inertia of an orbiting body is exactly balanced, that's the key word here, with the gravitational pull towards the body it orbits. Okay, that means that the tendency to keep on moving in the direction it's going, an object in motion stays in motion, is exactly balanced with the pull it's falling toward the planet. And that creates that stable orbit. A stable orbit happens when the inertia of an orbiting body is balanced with the gravitational pull toward the body it orbits. Now, body is, like Newton used that term body to mean any kind of planet, any object. I mean, this is a body, right? The moon is a body. The Earth orbiting the sun is a body. The sun is a body that it orbits. Okay, just to get that terminology. So you have that written down. If you need more time, then pause the video and write it down. Now, here's the thing I want to get into is his law. You might have noticed it showed up really fast here in that. I want to just a really quickie explanation on that. I don't want to get too much math, but I do want to talk a little bit about the actual law of gravitation because it is a formula. It's an algebraic equation, okay? And write these two things down because this is really what it says. The idea is if you translate that math into concepts, what it says is that you have two basic components to it. One, the closer two objects are, the stronger the pull. And the more mass two objects have, the stronger the pull. Okay, write those two things down. Because the closer the objects are, well, you can imagine that. Like if you get like too close to the sun, get pulled into the gravitational pull. The further you are away, the less gravitational attraction there is. And the more mass two objects have, the stronger the pull. Like the planet Earth has more mass than the moon. So when you figure out how much you actually weigh, what is the gravitational pull of you on the moon? You're about 1/6 of what you are when you're on the Earth, okay? So you don't have as much weight. The gravitational pull is less, so you don't weigh as much on the moon as you do on Earth. Or on the planet Jupiter, you weigh way more, and you couldn't even stand up, even if you weren't falling into this gaseous world. So the gravitational pull, it depends on how far the two things are apart and how massive they are, okay? And the closer they are, the stronger the pull and the more mass you have. And that would also mean if you have a golf ball, it has a certain amount of mass, and a bowling ball, it weighs more because it has more mass, so its gravitational pull toward the Earth is greater, right? So the more mass it has, the more it weighs. And the difference between weight and mass is actually, the weight is the gravitational pull. Whereas the mass is it's mass. It has other things. It's harder to push. Even in outer space and stuff, things have mass. So let me show you the mathematical formula and where that is. Again, I'm not going to make too mathematical, but this is what the formula actually says. Okay, so I want to show you the law of gravity, Newton's law of universal gravitation, okay? And so I know you might have seen it already on the thing. I'm changing the order up a little bit. But if you've heard of the law of gravity, the real term for it is law of universal gravitation. That means it works for any object, but it's sometimes called the law of gravity. The law of gravity is not something as simple as what goes up must come down. The law of gravity is actually an equation that Isaac Newton figured out. it's F is the force. Now, this is the gravitational attraction that two things have toward each other. By the way, you're being attracted to the Earth. Well, the Earth is being attracted to you too, but since you have so much less mass than the Earth, you're the one that actually moves. That has to do with Newton's second law of motion, F equals ma, but let's not go worry about it. So the force of gravity, F, equals, okay, I'll go ahead and write force. I can't, help it. And now you have this thing called the gravitational constant, okay? I don't want to worry about the gravitational constant. It is really fascinating when you get into high school and college. You can worry about it. I'm just going to put it in pencil because it's there. What that does is it's sort of nature's fine-tuning of how strong gravitational force is, okay? And it's really one of those things that if the gravitational constant was different, then the universe would behave differently than it does. Okay, so mass 1 times mass 2, okay? What this would be is this is the sun and this is the earth. Or this is the earth and this is the moon. Or this is earth and this is you. Or this could be a peanut and a french fry. It doesn't matter. Anything that has mass has gravitational attraction. Although if you have something the size of a peanut, it doesn't have enough mass to really produce very much. But right here, remember those two rules. The closer two objects are, the stronger the pull. And the more mass two objects have, the stronger the pull. This is the part that tells you the more mass you have, the stronger the pull. More mass more mass equals stronger pull. Okay, again, I'm not going to get, bogged down too much in the math, but this is these two things multiplied times each other. Okay, the mass of the earth and the mass of a person. Well, if a person weighs twice as much, you'd have the mass of the earth times the mass of that lighter person or a heavier person. The heavier person's going to weigh more. They get pulled toward the earth with more force, right? Okay, so these two things, it's a product of the two masses. So if you have the mass of Jupiter is bigger than the mass of Earth, so the gravitational pull on Jupiter is greater than the gravitational pull if you're on the Earth. Or the Earth has less mass than the Sun, so the gravitational pull of the Sun is less. The gravitational pull of the Sun is greater than the gravitational pull of the Earth, right? The more mass you have, the more gravity you have. Okay, this more mass equals stronger pull. Okay, now this bottom part of the formula, radius squared, is what the r squared stands for. What this is radius. So if you have like a circle, I don't know how much geometry you guys have studied. And you get the central point called the focus. This distance right here is the radius, okay? What that means is the distance from one point to another is really what it is, the radius of the circle. So now it might seem a strange way to say it, but it's true. No matter where you are on the earth, the point you're actually being attracted to is the center of the earth. You can think of the earth as the mass of the earth as one central point, but it's not like that one point has all the mass. It's like that's the average attraction of every atom and molecule of earth stuff that gets pulled, and it can be thought of as just a single point, right? Your center of gravity, just kind of like you had in the when you did the center of gravity in the pendulum labs, you had to measure to the middle. Well, that would be the center of that. Anyway, that's the radius is the distance between two objects is what it amounts to. And so what this is the bigger the number you have here, the greater the distance. Look, it's an inverse relationship because it's over that. So what you have here is the bigger r is, the less force you have. The greater the distance, the less force you have because you divide it by that. So you multiply times the masses. So the more mass you have, the stronger, but the more distance, the weaker. Okay? More distance. I'm hoping you're understanding this equals weaker. Okay? So the further you are, the weaker the pull. The closer you are, the stronger the pull. Okay, that's what that means. And this squared relationship means as you get away from it, it gets a lot weaker really fast. It's called the inverse square relationship. But again, we'll worry about that when you get into high school. Okay, so the law of gravity, this part says the more mass you have, the stronger the gravitational pull. This part says the more distance you have, the weaker the gravitational pull. All right, so I wanted you to see Newton's law of universal gravitation and translate that into concepts. All right.